Now, let's do the almighty Robin Williams test. So this was the one that I was a little bit worried about. So if we go and test him, drop the screen down so we don't have so much glare. So you can see he is unverified. The model is working. Let's try me again. Verified. 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 Alrighty guys, welcome to part 8 in the facial recognition and facial verification series, where we try to take a state-of-the-art research paper and go all the way to the end and finally integrate it into an app. And it just so happens that this is the final episode in the series, and we're going to be doing exactly that. So we're going to be taking our trained model and integrating it into a Kivy app so that we can actually use it practically in real time. Let's take a deeper look as to what we'll be going through. So as I was saying, we are in the final episode in the series, and this is all going to be to do with actually building up our Kivy app. So you actually get some practical use out of the hardcore deep learning model that we've actually gone and trained. Now we're going to be focused on 3 things as per usual, following the rule of 3s. So what we're first up going to do is we're going to set up Kivy. So Kivy is an open source framework that allows you to build applications with Python. What we'll then do is we'll build a lightweight facial verification app. So think of like Face ID for your phone, but we're going to be building it using Kivy. And then we're going to integrate our Tensorflow model. So we'll actually build up our verification process to be able to leverage this model inside of Kivy. Ready to do it? Let's get to it. Alrighty guys, so we finally got to the good bit. And this is where all our hard work finally comes together and where we're really going to be focused on integrating our TensorFlow deep learning model in to our Kivy app. Now, if you haven't heard of Kivy before, basically it's an open source framework that allows you to build applications, and I believe you can even build some native stuff all using Python, which works to our advantage because pretty much everything we've done so far has been in Python. So in keeping with that theme, we're going to be using Kivy. Now, specifically, in order to go through this, we've actually got a number of tasks that we need to go through. But before we do that, let's actually jump over into our whiteboard session and actually take a look at what we'll be building. Alrighty, so in this part of the series, we are going to be focused on building our verification app. So in order to do this, we're going to be focused on building our app with Kivy. Now, we're really going to have 3 main components that we need to handle. So say, for example, we've got our app. The first thing that we need to be able to do is grab our webcam feed. So over here, we're going to have our webcam feed. And in here, we're going to have the person that we're trying to verify. From that, we're going to have a button which basically says verify. And then down the bottom, what we're also going to have is we're going to have a label which says verified or unverified. So let's say this person is not me. Then right down here, we're going to say unverified. Now, in order to do this, we are actually going to be building up this app with a library called Kivy. And the cool thing about Kivy is it's an open source library for Python that allows you to build a whole bunch of different types of apps. So if you want to build stuff that integrates with your machine learning models, this is actually great. Now, we've actually gone and done a ton of additional work specifically so that we can hook in this bit over here to a webcam. So we're actually going to have a webcam that integrates into our Kivy app to actually give us this video feed. And that is the core premise of this app. So when we actually go and hit that verify button, we're actually going to trigger our TensorFlow model. So this is going to grab the webcam feed and it's going to go and verify against our Siamese Neural Networks. So imagine, I don't know how you draw it. Let's draw a little basic neural network. And from that, we're going to get either a 1 or a 0, a verified or unverified, and that is going to drive this outcome over here. And that, in a nutshell, is what we're going to be building. But we're going to be taking this step by step, so don't fret, we're going to be building it up together. All right, back to the code. And we're back. So in order to actually go and do all of that, what we're going to need to do is go through all of these 14 different steps. Now, fret not, a lot of the stuff that we've already done is going to be readily transferable to when we actually build this stuff up. So even though we've got 14 steps, some of them are going to be a lot easier than others. Now, first things first, what we need to do is go on ahead and set up our app folder. Then we're going to install Kivy and then bring over some existing assets. We're then going to focus on building our layout and our actual app. So it's going to be pretty simple, but again, you could extend this out if you really wanted to. And then we're actually going to bring over our verification components and tweak them a little bit so that we can get it to work with our app. But first things first, let's actually go on ahead and set up our app folder so that we can actually get stuff a little bit more structured. So I'm going to go into the same root directory that we've been pretty much doing all of our stuff in. And from within there, I'm actually going to create a new folder and I'm going to call it app. And to begin with, let's actually just grab our to-do list and let's actually dump it in there. So we've got all of our stuff in the same place and we can see it all together. And I'm going to open this folder inside of VS Code. Cool. So really it's all we've got is our to-do list inside of there at the moment. Really nothing too crazy over here. Now what we actually need to do is so we can actually mark this bit off. So that's done. The next thing that we need to do is actually go on ahead and install Kivy. Now this is pretty straightforward. It's just a pip install. So what we need to do is open up our terminal. And before I'm actually going to activate a virtual environment because I'm using one here. But if you're not, don't fret, just install it into your base Python environment. So let me activate this environment and then we should be good to go. All right, so you can see my virtual environment is called faceid, but that's perfectly fine. If you don't have a virtual environment, don't fret. You don't need to go and do that. Now what we can do is I'm just going to jump back into our app folder. Let's go on ahead and install Kivy. Okay, so before I run that, let's actually take a look at what we've written. So I've written pip install Kivy and then inside of square brackets full. So this is going to install all of Kivy, including its dependencies. And then we've also installed, or we've passed through the second argument, which is Kivy underscore examples. So this is going to install the Kivy examples components. Not mandatory for this tutorial, but I think it's, I actually had it as part of testing. So I've just kept it in there to make sure that we don't break anything. But I believe you could actually drop this and it should still run fine. Okay, so once you've written that, go on ahead and run it. And this should go on ahead and install Kivy. And you can see that it has in fact gone and done all of that. So it looks like we don't have any errors there. I've got this warning saying I should upgrade pip, but that's fine. We don't need to go on ahead and do that. Let's go on ahead and clear this. And so to clear in a terminal, it's just CLS. I can't remember what it is on Mac. Maybe it's clear. I can't remember. I don't do it too much anymore. But what we now want to do is just double check that we've got Kivy there. So if I run pip list, and if we go and take a look, you can see that we have in fact got Kivy there. So we've got all of our Kivy dependencies. That means we are kind of good to go. And we can actually mark step 2 off as done. All right, that is that done. Now our next step is to create our validation folder. Now what I mean by this is, remember in the previous video, what we did is we set up some validation images, and when we actually went to perform our verification, we didn't just do one prediction. We actually looped through all of the images inside of our verification images folder to actually go and get an accurate prediction, right? That is exactly what we're going to do here. So what we need to do is grab those images and bring it into our app folder. And that's exactly what we're going to go on ahead and do. So if we go back into our root folder, so remember faceid is my root folder. So I'm just going to grab this application data folder and I'm actually going to copy it. And I'm going to paste it into our app folder. And inside of that, we've actually got two things. So we've got one folder called input images. So this is the image that our webcam captures to verify against our 2 channels. And we've also got a bunch of other images, which are our verification images. So these are the ones that it goes and compares against. So that's pretty much that step done. So that one was pretty easy. So we just went and grabbed this application folder here. Let me zoom in so you can see it. So we grabbed that and we pasted it into there. So application data is now going into our app folder. Cool. Okay, so that is step 3 now done. So we've just brought that over. And this is really all just a bunch of setup. So nothing too crazy here. Now, the next thing that we need to do is create a custom layer module. So this is actually relatively straightforward, but let's actually take it step by step. So I'm just going to close this terminal now. And what we're going to do is we're going to create a new file. And this is going to be called layers.py. And for this, what we're actually going to need to do is we're actually going to need to bring in our custom L1 distance layer. So this is actually going to hold custom L1 distance layer module. Right. So what we actually need to do here is we need to bring in our dependencies, and then we're actually going to jump back into our Jupyter notebook and bring through our custom distance layer. And as per usual, guys, all of the code that I write in this is going to be available in the description below. So if you get stuck or you're not sure where to put stuff, it's all going to be available there, so you can actually pick it up. So first up, what I'm actually going to do is I'm going to set my Python interpreter. So if you've got a base interpreter, that's perfectly fine. Again, as I'm using a virtual environment, I can actually go into the virtual environment. So if you haven't seen how to build a virtual environment before, I've actually got an example inside of the 5-hour TensorFlow object detection tutorial. So I've just created a virtual environment called faceid. In that tutorial, I think I called it TFOD. When you're inside of VS Code, you can go and set that kernel inside of scripts, and then I'm just going to choose Python. Cool. So that basically means that when I'm coding inside of VS Code, I'm using the same kernel that I'm using to run stuff that I've actually used to develop pretty much the whole app. Cool. So what we now need to do inside of our layers file is we actually need to first up bring in some dependencies, and then we're going to go on ahead and copy over our custom L1 distance layer. So let's go on ahead and do that. Okay, those are our two main dependencies now imported. So I've written 2 lines of code there. So first up, import TensorFlow as TF. So this is going to bring in our base TensorFlow library so we can use it across the board. And then I've also imported the layer class. And this is really important when it comes to actually using or building up a custom layer. So for that, I've written from tensorflow.keras.layers, import a layer, and layer is in caps. Just pay attention to that. Now, the next thing that we need to do is bring in the custom L1 distance layer from Jupyter. So let's go and do that. So I'm just going to jump in. So I've already got the notebook already set up, and it looks like I've gone and killed it off, and that's perfectly fine as long as we got it open. So I just need to copy over this L1 distance class. So I'm going to copy that. And this was done in, I think, episode 4, and it looks like under step 4.2. So we're just going to copy this over. And the reason, let me actually explain the reasoning. So the reasoning that we need this, or the reason that we need this, is because when we actually go and load our custom model from a H5 file, you can see that we need to pass through our custom objects, and we need to pass through our L1 distance layer, which is our custom object. So that's why we're going to need it inside of our Kivy app. So we're going to go on ahead under step 4.2. We're going to copy everything to do with our L1 distance layer, and we're going to paste it into our layers.py file. That is that done. So let's just explain why. So we need this. Why do we need this? It's needed to load the custom model. And this is going to apply wherever you use custom objects with TensorFlow. So whether it be a custom layer, custom activation function, custom optimizer, custom loss function, you're going to need to do this, right? So just a key thing to note. All right, so that is our L1 distance layer now brought in. So we've gone and effectively brought that. Cool. So we can actually mark step 4 now as done. So far what we've done is we've set up our app folder, we installed Kivy, we've created our validation folder. So we brought that in. It's called application_data. And we have also created our custom layer module. Now, again, we've got another easy task here. We just need to copy over our H5 model from our root folder into our app folder. So I'm going to go and grab that. Remember when we went and finished training our model, out of it, we got this model called Siamese model.h5. So all we need to do is grab that and paste it into our app folder. That's that now done. Cool. So we can minimize that, and that is step 5 now done. So this is this is needed so that we can actually reload our model from disk. So basically when we actually go and use our model, we're going to be able to reload those weights up. Now we're onto the good bit. So this is where we're probably going to write a little bit more code. So we actually first up need to build our template Kivy app. So we're going to bring in some dependencies. We're going to build our layer. We're going to write our update function. And again, I'm going to go through this in detail, but our update function is going to be used to refresh from our webcam. So think of your Kivy app as standalone. We need it to be continuously updating so we can see our head moving inside of our app. And then we're going to bring over our preprocessing function from Jupyter again. Cool. But first up, what we need to do is import some dependencies. And you're probably thinking, Nick, where the hell am I importing these dependencies? Well, we actually need to create a app file. So we're going to call it faceid because that's really what this is all being to do with. We're performing our verification. So I'm going to create a new file and I'm going to call it faceid.py. And then from here, what we're going to start to do is import our Kivy dependency. So we're going to import Kivy dependencies first. And we're going to need some other dependencies as well. So import other dependencies, dependencies. And these are really going to be like TensorFlow, OpenCV, pretty much the stuff that we've used to actually build up our app. But first up, what we're going to do is we are going to import our Kivy dependency. So let's go on ahead and do that. Now, there's going to be quite a few, but don't fret. We're going to take a step back and actually take a look at what we've imported. So let's do it. Okay, that is all of our Kivy dependencies now imported. So we've gone and written, what is that, 8 lines of code there. Now let's actually take a step back and take a look at all the stuff that we've wrote. So these first two up here are all to do with our app layout. So for that, I've written from kivy.app import app. So this is going to be our base app class. Then I've gone and imported our box layout. So this is just the layout that our actual Kivy app is going to take. So if we actually go into our documentation and type in box layout. So basically this is sort of what we're going to be getting. We're getting a vertical or horizontal box. In our case, we're going to be using a vertical box because we're going to have our camera at the top, then a button, and then whether or not we're verified or not inside of our application. So we're going to be using this type of layout. Where are we again? So we're up to here. Okay, so that is our app class imported and our box layout. So from kivy.uix.box layout, import box layout. And this is in camel case. Cool. Then the next couple that we've imported are really just think of these as asset classes. So import Kivy, I'm going to call them asset, or actually the UX components, right? Really. So I've written from kivy.uix.image, import image. So this is going to be used for our real-time webcam feed. But you'll see that later because there's some magic trickery that we need to get in order to work. And then I've gone and imported the button component. So from kivy.uix.button, import button. Then I've imported a label. So this is going to allow us to work with text. So from kivy.uix.label, import label. So really 3 UX components. So image, button, and label. Then we've gone and brought in some other stuff. Import other Kivy stuff. And so the first thing that we've brought in there is from kivy.clock, import clock. So this is going to allow us to make continuous updates to our app. And this is what's going to allow us to get a real-time feed from our Kivy app, because natively we're not actually running a loop. So we need something to pre-process those updates to keep getting a real-time feed from our webcam. And this is what we're going to be using the clock for. Then I've imported texture. So from kivy.graphics.texture, import texture. And this is something that I had to play around with a ton when I was actually setting this up. So we actually need to convert our image from our OpenCV webcam to a texture, and then we set our image equal to that texture. So there's a bunch of messing around in order to get this to work, but it does work. I've tested it. So we've imported that. So from kivy.graphics.texture, import texture. And then I've imported the logger. So this is going to be towards the end that we actually use this, but it's going to make your life a bunch easier so you can actually see some metrics. So from kivy.logger, import logger. And this is particularly nice if you don't want to show this information to your users, but you still want to see how your app is performing and what's actually happening behind the scenes. So that is pretty much all of our Kivy stuff now imported. So all up, we've written 1, 2, 3, 4, 5, 6, 7, 8 different lines of code to import our Kivy dependencies. So let's save that. So that is our dependencies for Kivy now imported. Now, I didn't include it as a separate step, but we actually need to import some other dependencies as well. So while we're here, let's just go on ahead and import those. Okay, so those are our last couple of dependencies now imported. So
We've gone and written 1, 2, 3, 4, 5 different lines of code. So first up, what we're doing is we're importing OpenCV because we know undoubtedly we're going to need this when it comes to accessing our webcam. We've then gone and imported TensorFlow. So import TensorFlow as TUF. We've then gone and imported our custom distance layer. So this is coming from our layers.py file. So we're importing that. So to do that, I've written from layers, import L1 dist, which is bringing in this class over here. Then we're importing OS, so this is just going to make it easier to work with our file paths. And then last but not least, we're importing NumPy. So import NumPy as NP. So that is it when it comes to importing dependencies. And yes, we've brought in a ton, so there's a ton of dependencies. So the next thing that we actually need to do is, we can actually mark that as done, that's done. The next thing that we want to do is actually start building our layout. So let's go on ahead and do this, and then we're actually going to start our app and see if we can get it running. So let's start building our layout. So I'm just going to say build app and layout. Let's do it. Okay, so that is the shell of our app started. So I'm going to take this step by step as per usual, rather than going balls to the wall and actually building this all up. But so what we first up need to do is define our app. So in order to do that, I've written class cam app inside of caps, and then we're passing through our app. So this is going to ideally perform a little bit of inheritance so we can use our app. And then the first method that we've actually defined is the build method. So def build, and then to that we're passing through self. Build is a inherent function that you actually need to define when working with Kivy. So if you actually take a look, can we see it here? Let's go into our basics. So you can see in pretty much this one here is a good example. So this is an example Kivy app. So you can see that we've gone and written, or they've gone and written class test app, and then they're passing through app, and then they're using the build function. So again, we're pretty much following that structure as well. Cool, but that is the beginnings of our app now done. So we've written class cam app in caps, and then we're passing through the app class that we imported from right up here with a colon, and then we've written def build, and then we're passing through this ourselves, so the self object, colon, and then pass. So at the moment, we're not actually doing anything here, but we are in a second. And then we're just setting up our run. So this is just going to make it cleaner and ensure that we run successfully. So if underscore underscore name underscore underscore equals equals underscore underscore main underscore underscore quote colon, then we're going to run our cam app. So we're going to run cam, so capital C A M capital A P P dot run. So if we actually go and test this out now, the way that you actually run this app is just make sure you're in the same folder. So what we need to do is run Python faceid.py. Now we don't actually have our app actually doing anything at the moment, but this is effectively what's going to run once we've got that running all successfully. So again, nothing's going to open up because we don't actually have anything running, but it doesn't look like we've got any errors just yet. So it looks like we're all good. Well, okay, so we do have a bit of an error, but that's perfectly fine. We're going to get to that in a second. So what we now need to do is finish building up our build function. So let's go on ahead and do a little bit more there. Okay, so those are the beginnings of our layout components now written. So we've gone and written 3 additional lines of code there plus 1 comment. So really this is going to form the base structure of our app. We're going to have an image at the top, which is really going to be our real-time webcam feed. We're then going to have a button which we click to go and verify, and then we're going to have a label at the bottom which basically tells us either the verification hasn't started, it's completed and you're unverified, or it's completed and you are verified. So let's actually take a look at these. So we've got 3 different objects. So we've written self.image1. So this is going to be our main image. And we could actually make this image, but I'm just mindful that we might have certain classes that use image. And then we've actually gone and used our image class from up here. And we've passed through 1 keyword argument, which is size hint. And we've set that equal to the full width, but 0.8 worth of the horizontal height. So basically this is sort of setting the dynamic layouts of each one of these components. So our image is going to take the majority or 80% of our vertical height. Then we've set our button. So self.button equals button. And remember, this is going to be importing from the button class up here. And we've gone and passed through 2 keyword arguments. So we've gone and set our text equal to verify. And what we're going to need to do eventually is set the onPress function to be able to run a certain function. But because we haven't defined that function yet, we're not going to do that. We'll come back to that. So we've written text and then we've set that equal to verify. So our button is actually going to say verify. And then we've set our size hint equal to 1. So the full width, but only 10% of the height. So we've got 1 and then comma dot or 0.1. And so remember with our image, we set our size hint to 1, comma 0.8 inside of a set of braces, which means it's a tuple we're passing through. Our size hint for our button is going to be 1, comma 0.1. Cool. So really just think of this as text and then how big or dynamically how big you want that button to be. And then we've set our verification. So this is going to be our text, which actually tells us whether or not we're verified or not. So I've set that equal to a variable called verification. So we've set self.verification equal to a label, which is from right up here. So we set, remember, our 3 core UX components, so image, button, and label. We're using them right here, image, button, and label. So again, we've gone and set 2 keyword arguments for our label class. We've set text equal to verification uninitiated. This is going to be what it starts off as, right? So eventually, once we go and trigger our verification, you'll actually see that it goes verified or unverified. But for now, we are going to set it to verification uninitiated, and we've set our size hint to 1, and then comma 0.1. So there's just a couple of additional lines that we need to write before we can actually kick this off and see some stuff. So let's go on ahead and write that up. But first up, just I guess to recap there, we've gone and created 3 new components. So an image, a button, and a label. And these are going to show up in our app in sequential order. So we'll see our image first, which will eventually be our webcam feed, then a button, then a label. All right, let's go and finish this up and at least test this layout out. Okay, so that is our layout now pretty much done. So I think this is the shell of our app now effectively set up. So I wrote an additional 5 different lines of code there. So first up, I've written layout. I've created a new variable called layout, and I've set that equal to box layout. So remember how I was describing right at the start that we had this box layout class, which basically either gave us a horizontal layout or a vertical layout. So we've gone and set that to vertical. So our objects are going to appear in sequential order from the top down. So we've gone and written layout equals box layout, and we've set orientation equal to vertical. And then we've just gone and added our 3 widgets. So keep in mind, right now we've created these UX components, so image, button, and label, but we haven't actually added them to our layout. So this is akin to creating a module in Python, but not actually importing it into your notebook. So we've created these UX objects, but we haven't actually added them to our Kivy layout. And that is exactly what we do here using the add widget method. So I've written layout.addWidget, and then we're passing through self.image1. So it's coming from up there. So it's going to be our image, and then layout.addWidget, and then we're passing through self.button. So we're adding our button to our layout, and then layout.addWidget, and then we're passing through self.verification, which is going to be our verification text. So I think based on this, we could probably actually try starting this up and see what we actually get. So let's try running Python. Now let's clear this so it's a little bit clearer. So we're going to run Python and then faceid.py. Let's see if that opens up successfully. And we've got, so run is missing 1 positional argument self. Oh, we've actually gone and defined this. This should actually be the actual class. So I've gone and missed out a set of parentheses there. So let's actually try that again. So before we had no parentheses there, and I was wondering why it wasn't actually working, but we actually need a set of parentheses down here because otherwise we're just referring to the class. We're not referring to our particular instance. Cool. Or we're not creating a new instance. So let's actually go and try that. That's looking positive. And there you go. So that is our base layout. So it looks kind of shitty right now, but that's perfectly fine. We're going to add our webcam in a second. But you can see that we've got our button. Let me zoom in on this so you can see it a bit better. So this is eventually going to be where our image or our webcam feed is going to be. But we've got our verify button and we've got our label down the bottom, which says verification uninitiated. So we can click our button, but right now it's not doing anything because we haven't actually hooked anything up to it. But that is our base layout now done. So we've got our verify button and we've got verification uninitiated. So if we actually close this, it's going to stop everything down. Now, just to prove to you how this sort of widget layout works. So if we actually went and sub these around, so say we put the button below verification, let's actually see what that does to our layout. All right, so let's try running that again. All right, so you can see that our text is now above our button, right? That actually kind of looks better than what I had, but that sort of gives you an idea as to how this actually works. So the layout is in a sequential order. So the way that you add the widgets are going to determine how our layout actually forms. Let's actually add it back. I wonder if hot reload will actually pick this up. No, it's not going to pick it up. That's perfectly fine. So we're going to shut it down. And if we rerun it again, you can see that our order will be back to normal. So it'll be image, button, and then label. So image, button, and then label. Cool. That is the beginnings of our layout now successfully done. So what is that? So we've actually gone and done step 7. Now done. Pretty cool, right? So that is the beginnings of our layout. Now the next thing that we actually need to do is actually set up a feed from our webcam. So at the moment you saw that we had that sort of blank area at the top for our webcam, but it's not actually doing anything as of yet. Well, what we need to do is we need to set up OpenCV to be able to grab our webcam, and then we need to refresh that image so that we're effectively looping through and continuously reading the feed from our webcam. And that is effectively what we are now going to go on ahead and do. Okay, so first up, what I'm going to do is I'm going to create a captcha inside of our build function. So this is going to be from OpenCV. So let's go on ahead and do that. And then we need to go and create an update function that basically we use to update our feed. So let's first up go and set up our captcha. And this is really no different to how you'd go and set up a video capture device when you're working with OpenCV. So let's do it. Okay, so that is our video capture device now at least initiated. So I've written self.capture and I've set that equal to cv2.videoCapture and I've set video device 4. Now you might need to play around with this depending on which device your webcam is. I say it all the time, and I'm currently working on an OpenCV series to show you guys how to actually determine what that number is. But on my machine, it's going to be 4. If you have no other webcam devices apart from your main webcam on your machine, then it's probably going to be the video capture device 0. But you might need to play around with this in order to get your webcam feed up. So I'm going to set it to 4, but I might also, if I didn't have any other devices on my machine, I'd probably set it to 0. To make sure that I actually get a feed. If you get something returned back which sort of says like CVT is empty or CV2.empty or CV2 having issues with I am right, it's probably because either your webcam is unavailable or you've got your video capture device number set incorrectly. Okay, so now that that is done, we actually need to do something to actually update and read our feed from our webcam. So we're actually going to need to use our clock function or our clock class to go and set a schedule to continuously run this function. But first up, let's actually go and define it. Okay, so I've gone and set up a new function called update. So this is going to run continuously to get webcam feed. So there I've written def update, and then I'm passing through 2 positional arguments. I've written self, and then we're going to unpack all of the other arguments that are passed to it. So really it's just def update, and then we're passing through self, and then asterisk args. Then I'm closing out the function, and I've passed through a colon, and at the moment I've just set that equal to pass. So if I actually went and ran this right now, you wouldn't actually see anything different. So again, to run it, we just run Python and then faceid.py from that folder. So if we're going to take a look at this, it's really going to be no different. Right? So right now that we haven't actually done anything. So we're not actually, 1, rendering our image to our layout, and 2, we're not actually running this update function as of yet. So we need to go and first up write this update function and what it's going to do, and then we actually need to trigger it from up here. So let's go on and start writing up this update function. Okay, so the next two lines that I've written are basically going to read our frame from OpenCV. So I've written ret, comma, frame, and these are really just sort of standard OpenCV lines. And if you actually take a look inside of our Jupyter Notebook, we would have written this inside of our real-time test. So exactly the same as what we've got up here. Nothing crazy. We actually don't have the last channel, so if I do that, pretty much identical then. Okay, so that is basically reading in our frame from OpenCV. So I've written ret, comma, frame equals self.capture.read. So this is grabbing our capture device from up here, and it's reading the frame, and this is going to return two things, a return value and the actual frame as a NumPy array. Then we're cutting down our frame. So rather than having the full, 480 by 640 pixels, we're actually going to cut it down and be 250 by 250. Which is effectively what this slicing is doing here. So I've written 120 colon 120 plus 250. So we're effectively going to start, never remember whether or not it's height or width first. So I think 120 is going to be the shorter. So that's going to be height. So we're effectively going to be grabbing 250 pixels from our height, and then we're going to grab 250 pixels from our width. So we're cutting down the image. So we've only got a little square box. So 120 colon 120 plus 250, comma, 200 colon 200 plus 250, comma, and then colon to grab all of our channels. Cool. That is our frame now captured. Now, again, we could run this, but we're not going to see anything to the screen. So what we need to do is actually go and update this image from over here so we can actually see it. So that's effectively what we're going to do now. So let's wrap this up, and then we're actually going to set up and trigger this update function. Okay, so that is effectively going to go and apply our image texture to our image from up here. Now, I'm really not happy with calling this image image one, so I'm actually going to call it self.webcam. So we're going to change that up there, and what we also need to do if we're doing that is we need to change that down here. So let's actually, so what I actually went and did is I went and rewrote to self, instead of self.image1, I've written self.webcam. So let's actually change that webcam. That makes more sense. Cool. All right, so rather than that being image one, that's now going to be webcam. All right, then let's actually take a look at the 4 lines of code that we wrote down here. So I've written buff equals cv2.flip, and then we're passing through our frame and specifying 0. So this is going to flip our image horizontally, and we're going to convert it to a string. Then what we're doing is we're actually commencing the conversion of our image to an image texture. So this is basically just a format that I realized I had to go and convert it into so that we can get our frame to show up. So basically there's a bunch of arguments, but it effectively allows you to convert this image into a texture. So let's actually take a look at that. So I'm going to open up the doco, texture. And it is this. So the texture is a class that handles OpenGL textures depending on the hardware. Some OpenGL texture, depending on the hardware, some OpenGL capabilities might not be available, blah, blah, blah. So basically what we're doing is we're actually converting our image to this texture, and it's pretty much what you can see down here. So this allows us to actually see this image on our screen, and we do use this blit buffer function. So this actually converts we first up convert our image into a buffer, and then we effectively render it as a texture. The full line of code, or next couple of lines of code that we've written, is image underscore texture equals texture dot create. And then we're setting that, we're passing through a 2 keyword arguments, so we specified size, and then to that we're passing through our frame height and width. So frame.shape1, comma frame.shape0. And we're setting that inside of a tuple, and then we're passing through a keyword argument called color format, and we're setting that to BGR because that is the way that OpenCV actually brings in an image. And we've got a error there. I don't think that's wrong. Expected expression. I think this is actually should be fine. I remove that. What are we getting? Okay, yeah, sorry, no, we actually did have a second one because I added it in there. Okay, that's fine. And then then what we're doing is we're converting this OpenCV buffer, which we had over here. So remember, we set that equal to buff, and we're actually applying our OpenCV image and converting it into a texture. So that is effectively what we're doing. We're taking our image, we're converting it into a texture so that we can render it inside of our app. So then we're using image underscore texture, and then we're using the blit buffer method, which I just showed, and we're passing through this OpenCV string function or string value that we had from over here to this blit buffer method. So we're grabbing this, we're passing it through to blit buffer, then we're setting color format equal to BGR again, and buffer format equal to ubyte. Then what we're doing is we're actually grabbing our webcam object, which was all the way up here, and we're setting the texture for that equal to image texture. So again, it's a long-winded base process really, but what we're doing is we're getting our image, we're flipping it horizontally, we're converting it into a texture, and then we're setting our webcam image object from up here equal to that texture. So basically it's a long-winded way to be able to effectively render our image in real time. Okay, now that that's done, what we can go on ahead and do is, I'm a little bit concerned that we've got an error there. Expected square bracket, why? I don't know, we'll leave it, we'll come back to that if we get any errors. So now that that's done, we still need to actually go and run this update function. And this is where our clock class is going to come in. So let's go on ahead and do this. Okay, I think that is pretty much it done for our real-time feed. So I've gone and written one line there. So I've written clock.schedule interval. So think of this as triggering off a loop, but basically it's going to tell our app to go and run a certain thing every X number of periods. So I've written clock.schedule underscore interval, and then we've set that equal to self.update. So we're actually running this function on this interval. So clock.schedule underscore interval, and then inside of that, the first argument is self.update. So what is it that we actually want to run? So it's going to be our update method. And then we're specifying how frequently we actually want to run that. So if we actually go and take a look at our schedule interval function, so schedule interval, you can see that this is going to be, so schedule an event to be called every X seconds. So it says timeout seconds, but it's basically how frequently we actually want to go on ahead and run this. So we are going to be running it once or 33 times every second. So that's 1.0 and then /33 divided by 0. So basically it's going to keep running and ideally mimic what you'd expect to see with the human eye. Okay, that's a lot of work to be able to get a real-time webcam feed. So it is a little bit tricky with Kivy, but basically we've gone and defined this huge update function, and we've gone and defined our video capture devices. So all things holding equal, still a little bit concerned about this, why we're getting an error there. Pretty sure it should be fine, but that's fine. Let's go and test it out. So I'm just going to clear this so it's a little bit cleaner. So we are going to run Python faceid.py. We're still getting that error. Why? Oh, because we're not actually grabbing an object. This should be frame. There we go. All right. All right. So if we go and so basically I was slicing nothing, which is why it's saying, hey, we expected a square brackets, but right now we don't actually have anything in there because it's actually telling us convert that into an array. But we don't want to convert that into an array. We want to slice our array. So if I type in frame, that is going to fix that up. All right. Let's go and run this now. All right. Fingers crossed. Let's see if that works. Oh my God, it's working. So you can see that we now have our webcam feed. So that's my little head in there. And you can see that we actually have our real webcam feed or real-time webcam feed now appearing inside of our Kivy app. So that, I know it was a lot of work to be able to get that, but you can see that the speed is pretty quick. We've got our face there. And this is akin to what you might have when you're using like Face ID on your iPhone. So that is very good. So we've now got that successfully running. So I know we can bask in the glory. We've got this up and running. It's pretty much it. Like, honestly, guys, that was successful. No, we're not going to stop there. So let's go ahead and close this. Go back to our to-do. All right. So we have now successfully gone and done that. So we've gone and built up our update function, and we've gone and let's actually say and render webcam. So a lot of effort to go on ahead and do that. But basically what we did in that section is we went and First up, set up our capture device to be able to go and get our webcam. We then went and wrote this huge update function, which is basically, it's not huge, which is basically reading our webcam feed. It's slicing down our image so that we've only got 250 by 250 pixels. We're then converting our OpenCV array, which is an image, into a buffer, and then we're converting it to a texture, and then we're actually rendering that to this webcam object from over here. And then we're triggering it. We're using the schedule interval function to be able to go and trigger our update function so it's in real time. Okay, that's a lot. Now, the next thing that we need to do is what? So we now need to bring over our pre-processing function. So remember, we need to pre-process our image before we pass it to our TensorFlow model. So that is what we're going to go on ahead and do. And it just so happens that we can just grab this out of our Jupyter notebook. So the pre-process function is towards the beginning, I think. Where do we do this? This was probably during the data engineering bit. Pre-process twin should be close. Pre-process, we need this. So we're just going to copy this and we are going to paste it into our app. And we're going to tab that in. Cool. That is our pre-process function now brought in. So we could clean this up a little bit, but I'm not going to bother. But basically, we've copied in the function that we defined in step 3.2. So that meant it would have been in episode 3, where we basically go and pre-process our image from a file path. Now, the reason that we're going to use this is when we go and perform our loop, we're going to pick up our images from a file path. We're going to pre-process it, then pass it to our model. But that is that step now done. So again, pretty straightforward. So we grabbed our pre-process function and dumped it inside. So if I just zoom out a bit, because we've got a lot in here. So by now, inside of our cam app class, we should have 3 different methods. So we've got the build method, which is our base method. We've then got our update method, which is running every 1/33 seconds to be able to update our webcam. And then we've got the pre-process method, which is what we're going to use in a second. So we can save that. Let's go back to our to-do. So we've now gone and done step 9. Zoom back in. Okay, then the next thing that we need to do is bring over our verification function. So let's go on ahead and grab that as well. So I'm just going to say, let's actually add a comment here. So this is going to be used. So our pre-process function is going to be used to load image from file and convert to 100 by 100 pixels. Okay, now the next thing that we're going to do is bring over our verification function. So bring over verification function. We're almost there, guys. We're getting close now. So let's go on ahead and grab that. So that is towards the bottom. After that, it's after step 6. Wow, we wrote a lot of code for this, didn't we? Okay, so it's over here. So we need this verify function over here. So I'm going to copy that. And I'm going to paste that in here. Let's tab this in. Okay, so that is, that's a terrible comment. So verification function to verify person. Okay, so what we now need to do is let's save that. Looks like we've got a few errors, so these are easily solved. We'll come back to that in a second. So that is our verification function now done. So we can set that to done. Now let's quickly take a look at that verification function because we've already got a few errors, and this is because it is asking to pre-process or use that pre-process function, but we don't actually have that defined because we need to type in self.preprocess and self.preprocess. And we are still having errors, and that is because we need to pass through self over here. Oh, and we also need to pass through self over here. That's why. Okay, cool. Sorry, that's my bad. So the reason that we're getting errors is we're not actually passing through our current class to our verify function. So as soon as we add self there, we should be good to go. Okay, so there's not much left to do now. So what we want to do is we effectively need to just ensure that we save down an image from our webcam, because remember when we had our loop previously, we effectively took a snapshot from our webcam. We then saved it into this path over here. So application data and then input image and then input image.jpg. So we need to ensure that we save our current image into that folder as well. So what we're going to do is do exactly that, and then we should effectively be able to go on ahead and build this. We also need to load our current model. So we've got this. We can actually probably remove these. Yeah, let's just make sure we can handle any args. And then what we're going to do is we're actually going to set our detection threshold. Let's set that to like 0.5 as per usual. What was the other one? Verification threshold. So these are going to be the metrics that we use to determine how tight we want our detections to be. So we're going to set those first. Specify thresholds. And then what we need to do is capture input image from our webcam. And we're going to specify a save path. I'm going to set that equal to this. So effectively what we're going to do is we're going to capture a real-time feed from our webcam. We're going to save it into this folder, which is going to be application_data, input_image, and then input_image.jpg. So if we actually go in, actually we don't even need to do that. We can go from here. So if we go in application data, input image, and we're going to effectively replace this image. So that's what we copied over from our existing, from our existing code inside of our Jupyter Notebook. So we're effectively going to be replacing that. So let's finish writing out the code to actually go on ahead and save our image from our real-time webcam into that file path. Okay, I think that is looking good. So we've just gone and written, pretty much replicated what we had from up here in our update function to be able to save out our image. So I've written ret, frame equals self.capture.read, and then we're effectively reshaping our image to be in the shape of 250 by 250, and then we're going to be writing that out to our save path. Now keep in mind that we've still got a couple of things that we need to handle, right? So right down here, so we took out the existing arguments from our verify function, and now we're getting this error over here, which is saying model.predict is having errors. And this is because we haven't actually gone and reloaded our model, and now that we've taken it out of our function. So what we actually need to do to solve that is we're actually going to load our model inside of our build function. So I'm just going to set this to, let's actually go to our build function and load that in first. So under our layout, I'm going to say load Keras model, a TensorFlow Keras model. And we're effectively just going to load our model. So we're going to create a new variable called self.model, and we're going to set that equal to how we actually load up our Keras model. So let's go on ahead and do that. Okay, so that is our model now loaded. So I've written one line there. So I've written self.model equals tf.keras.models.load_model. So that's actually going to load up our model from our H5 file. So we've written load_model and then Siamese model.h5, and then we're passing through our custom objects. So custom_objects, and then inside of squiggly brackets or inside of a dictionary, we're specifying L1 dist or the L1 dist key. Oh, don't screw that. We're setting that equal to L1 dist or the L1 distance layer that we had from up here. So that is our model now loaded. Now, if we go back down to our function over here, inside of this line here, which says result, we can change that to self.model.predict. Cool. I think that is looking good. So wait, hold on. We've got one more thing to do. So we haven't actually gone and updated our verification label, right? So if we take a look, remember we had this verification label here. We actually want to output whether or not we've successfully verified or not. Let's actually quickly take a look at our to-do list. So update verification function to handle new paths and save current frame. So we've done that. We just did that there. So that is effectively what we did here. So when somebody goes and clicks verify, this is going to trigger. So we're going to go on ahead and save our image from our current frame. So we're going to run self.capture.read, get the current frame from our webcam. We're then going to cut it down and we're going to save it inside of this save file path. So we should effectively see our input image change every time we hit verify. But what we actually also want to do is we want to update this verification text. So it goes from verification uninitiated to something else, right? And that is effectively what we're going to do down here. And then we should be kind of done. What else do we have to do? Oh, we're actually up to that step. So update verification function to set verified text. And then we need to specify, link the verification function to the button. Yeah, we've got to do that as well. Okay, cool. So let's do the text bit first. So let's go on ahead and do it. Okay, that is our verification text now done. So we are going and effectively updating our verification object. Hold on, wait. We are overriding this object over here. So this is no good. We got to change that. So this over here, we're going to change this. So if I leave it as it is, we're actually updating. This might work. Let's actually just play it on the safe side. So I'm just going to convert this object here to be verification text. And I'm going to set this, actually let's say verification label. And verification label over here. So I don't know if you saw what my error was there, but basically we've got from our existing verification function, we've already got a variable called verification. So rather than have overlap, even though we're getting this one from our object, I'd rather keep it nice and clean. So I'm just going to change this to verification label. And remember, our verification function is going to return back this verification value here. And this is whether or not our detection is actually passing our certain threshold. So what we actually want to do is we don't want to go and overwrite this verification object. We want to set our verification label equal to verified if that verification comes back as true. Otherwise, we want to set that label to unverified if it's false, right? So I don't want to go and overwrite that label. Hence, what we did is right up back in here inside of our build function, we've gone and converted that verification object to be called verification, and we've converted that over to verification underscore label. So that should be okay. And then down here, what we're doing is we're setting self.verification underscore label.text equal to verified if verification comes back as true. Add a space there. Else, we're going to set it to unverified. So we go and save that now. I think there's only one last thing to do. So that is done. Two more things. And so the last thing that we actually need to do to test it out is to link this verification function to the button. So what we need to do is go right back up to our build function, and inside of this self.button class here, or variable or object in this case, what we're going to do is we're going to set onPress equal to, what is it? So self.verify then. Yep. So we're going to be setting it, running that. So it's going to be self, where are we typing this? Delete that. So right up here inside of our build function, we're going to set self.button equal to self.verify. We need to run that class. Yep, that's fine. Cool. Alrighty. I think that is good to go. All right. We wrote a lot of code there without running, so it'd be interesting to see if this works. So let's run it. Looks like it's successfully loading our model down here. Okay, so no errors yet. Let's see if this runs. I've clicked our button. Looks like stuff's happening down the bottom. Okay, and that said unverified. Okay, that is perfectly fine. But that is good. So what we're actually getting at is it looks like our verification function is actually running. So if I go back into the screen a little bit more, what about if I did it from here? Make sure that our new image is being written out. I go into D drive, and then where are we? So YouTube, Face ID, app, and then application data. And if we take a look at our input image, okay, so that is good. So our input image is being written out. Unfortunately, it looks like we're unverified. What if we take the green screen down? So if I go and run that. Okay, so we've got a new input image. We can see that that's saving. Still coming back unverified. New image. Okay, so that one said verified. Take a look. Verified again. Put my hand up. Unverified. Unverified. Verified. Oh man. It's working. How good is that? So if we try it again, oh, it's a bit blurry. We'll see if that works. Unverified. Verified. Cover our face. Unverified. Verified. Success, guys. That is your very own Face ID app that is now successfully running. Now, I wanted to show you guys a little bit. Let's actually test it out a little bit more. So what happens if we put another person's face up against, well, if Mike was away, what happens if we actually put somebody else's face up against this? So if I went and got Jim Carrey, my guy, let's try this. So if I go and put, the glare's a little bit much. Do we verify against? All right, Jim's unverified. Let's try someone else. Robin Williams. Try that. Come on, focus. Focus. Oh, it's verified Robin Williams. That's terrible. Okay. Okay, so now it said Robin Williams is unverified. Weird. That's me verified against the green screen. Huh, I wonder why it wasn't working before. Still verified. Hand up. Verified again. Interesting. I wonder if this is going a little screwy. All right, so see here, now we're sort of getting on slightly less reliable results. Let's try dropping the green screen. A hand up. Unverified. Hand away. Verified. Hand up. Unverified. Hand away. Now we're unverified. Come on, verify. Okay, that's verified. All right, so we need to play around with this a little bit more. But you can see here that sometimes we're getting good results. Other times we're maybe not getting such great results. And this is ideally where you want to have some logging set up so that you can actually see how well or not well your model is actually performing, because you might need to tweak those detection metrics, right? So what I'm going to do is I'm going to close this down and I'm going to show you how to log out some data. So let's actually go into our verify function, and we're actually going to use our logger method, which is, well, this is step 13 now done. We've successfully verified, guys. I know it's taken a long time, but we got there. Last thing to do is set up our logger so we can actually see what proportion of detections are over a certain threshold. So let's actually go and do this. So inside of our verify function, we're going to use our logger to log out some metrics. Okay, so those are two lines that I've written for our log. So I've written logger.info, and to that we're going to be passing through our results, which we get from over here. And this is from our existing verification function. And then I've also started to calculate a couple of metrics. So basically this line here is determining how many of our results are actually surpassing the 50% threshold. So I've written logger underscore, actually this is not written right. Yeah, this should be like this. Like that, my bad. So this is actually going and calculating what proportion of results are actually surpassing our 50% confidence threshold. So I've written logger.info, and then inside of that, we've got our results, which is inside of a NumPy array. And we're specifying what proportion of those results are greater than 0.5, which is 50%. And then we're summing those all together. So we'll have the number of results that surpass that threshold. So what we can also do is just throw out a couple extra of these. And let's actually make a couple more thresholds. So let's say 0.2, 0.4, 0.5, and 0.8. Now, if we go and run this again, we can actually get some additional info as to how well our Face ID model is actually working. So when you actually run the logger, you're actually going to see the output inside of the console. So this is much nicer if you're a developer actually building this up, rather than having this actually showing to your user. You can actually just have it sort of inside of your log, or if you wanted to actually go and log it out, it's going to look a whole lot nicer than actually showing it back to user. So also with the Kivy app, it's resizable, right? So if we wanted to make it a little bit tighter, we definitely could. So that looks a little bit better right there. Okay, so let's go ahead and test it out. So if I go and drop it down here, drop it low, girl. Right, so we can see what proportion of our detections are showing up there. So 50, how many images do we have inside of our verification folder? Oh, so this is saying 50 over 50, 50 over 50. Pretty much all of them are actually being matched. Kind of crazy given we've got a green background. Let's see about Robin. All right, so we're getting 42, 38, 37, which is what, wait, hold on, this is coming back unverified now. Input image, so we're getting Robin. What was our detection threshold? So we had 50%, 50%, so 37 would surpass 50. That should come back, I would have thought that should come back with verified. But it's good, I mean, it's coming back with unverified. Let's see it again. Focus. All right, let's see that. Okay, unverified. So this is basically saying that 32 out of the 31, it's getting 32 out of 31 matches. So if we go and bump this up higher, that seems a little bit weird. So let's say the verification threshold, rather than being 50%, let's set it to, I don't know, 80%. Let's try Robin again. Let's restart our app. And this is some of the tuning that you'd ultimately have to do, guys, as you're building one of these models. So keep in mind that once you train your model, it doesn't end there. You got to have to normally you want to have to be retraining this. All right, so that is centered-ish. All right, let's see now. Okay, so now we're getting less. So again, he's unverified. What about ourselves? Okay, so we are way more accurate over here, right? This is not making sense. So we're getting 47. So what proportion are surpassing 80%? So we are getting unverified back. So these are our results. So we can actually see these down here. So we are getting pretty good detection metrics. But our text down here is still saying unverified. So we are getting some ones that are super low. So take a look at that, 0.09. But the majority is still pretty good. So I wonder if we've got some issues with our detection threshold. So let's try that again. I wonder if it's delayed a little bit. Still unverified, still unverified. What if we drop the green screen? Still unverified. And this is because we've gone and bumped up what? Our detection threshold. But down here, we're saying that we're still getting 44% surpassing the 80% threshold, which would indicate, so what is this actually doing? So it's going verification equals detection divided by how many images we've got inside of here. I would have thought that this would have come back as true. So if we actually go and drop this back down. So this is some of the stuff that you might need to play with. I mean, ultimately it works. It's just fine tuning how accurate our model actually is. Let's verify now. So now we're getting, do we change this back? So we are at, what's our detection threshold? Our detection threshold right now is at 50%, and our verification threshold is also at 50%. But we are saying down here that our the proportion of results that are above 0.2, and we're summing them. So this, I've got a feeling we've got something incorrect over here. So this is saying np.sum. Let's log out our detection. So logger.info and detection. So our detection is going to return back the number of results that surpass our detection threshold from up here. So let's go and check this out. I mean, it works. I'm just, I want to make sure that we get this right. Right, so if we hit verify, ideally we should get the number that is being used to calculate the metric. So that is saying 47, right? So this is 47. Does that say verified? Unverified. Verified if so verification equals detection divided by the length of the number of images. So 47 divided by 50. So print out verification. Let's delete this, we don't need that. And let's print out verified. Logger.info. Print out verified. And so this is the advantage of having your logger, right? You can actually output and tune these models. So rather than just leaving it there, you can actually go and fine tune and actually see where stuff is going right and maybe where it's not going so right. So here, what I'm actually doing is I'm actually logging out the detection value, the verification value, and then whether or not we're getting verified back. So let's see. So if we go and run this now, we should get back those 3 metrics. Okay, so we had 43 detections, which surpassed our verification threshold. And we are getting 86%, and we're getting back the value true. And it's saying unverified. All right, so we do have a bug there. So verification, guys, here it is. So this should actually be verified. So rather than this value here being verification, this should actually be verified. So if self.verification underscore label.text equals verify, or basically we're specifying if verified equals true, then return verified, else return unverified. So this was verification first, which would actually return a detection value divided by that. So it's not actually returning. Kind of weird that it will getting verification then. I don't know. Let's go run this. And that is the advantage of using the logger. You can actually find out where stuff is going right or wrong. If we go and verify with a blurry image. All right, so now we're verified. Cool. And we're saying that we had 50% surpassing the threshold. We had 100% verified, so we now are true. So if we go and put my hand in front of it, let's see. All right, so that's still surpassing. I think we need to bump this up significantly. So our detection threshold, let's set that to, I don't know, 80%. Let's try that again. Okay, so we're getting verified. What happens? Put my hand up. We're still getting verified there, all right? So we might need a little bit of fine tuning. That's perfectly fine. Go and put our face. All right, so that's going up. Kind of weird that when you put your hand up, it's still saying you're verified. All right, let's try somebody else. Try old Robin, old mate Robin. It's verifying against Robin Williams. No, that is not acceptable. So we got to bump this up. So let's say a threshold should actually be 90. So what are we getting back? We're getting back very accurate results down here. So if we actually set this to 0.99, let's see how that works. Kind of weird that it's verifying against him appropriately. All right, so that's us verified, and we are getting back all of our positive results that are surpassing it. Let's try Jim. I don't know, maybe Robin Williams is able to bypass our threshold. And it's saying that Jim Carrey is verified. We're getting 0.99. There is something not going quite right here. So that input image is saying that we are verified. Wait, hold on. Where are we running this from? Let's bump up our thresholds again. All right, so that's me verified. What about Jim? Okay, so Jim is unverified. So I've gone and set the thresholds really, really high now. So our detection threshold is 0.99 and our verification threshold is 0.8. So if I go and do myself, we are verified. If I go and do Jim, Jim is unverified. Okay, so in this particular case, we had to set our detection threshold super high to ensure we didn't let Jim in. But in a nutshell, that is our Kivy Face ID app now done, guys. So again, you might need to do some tuning with your detection thresholds and verification thresholds. So I've gone and set it super, super high. So basically our detection threshold is 0.99 and our verification threshold is 0.8. Now, keep in mind what you could also do to hedge against any of these types of issues is you could have way more images inside of that verification folder so that you get a better chance of busting out anybody that's trying to break in versus letting people who aren't necessarily verified through to your app. But in a nutshell, that is our app now done. You could also go and train your model a ton more as well. So we can say that our logger is now done. So we've gone and done a ton of stuff, guys. So we went and imported all of our Kivy stuff. We built our camera app. We went and wrote our update function, brought in our preprocess function and update our verified function. And I sort of showed you how to tune this detection threshold as well. So remember, the logger is super important and it allows you to see what your detection results actually are like. And in this case, you don't want to let Jim Carrey or Robin Williams through. So you want to ensure that you set these appropriately. So the metrics that I ended up with were a detection threshold of 0.99 and a verification threshold of 0.8. So again, we could set this even higher if we wanted to. We could even add more images into our verification folder. But on that note, that about does wrap it up.
Hold it right there. So while this model and this application worked, it was far from perfect. You saw that Robin Williams was able to bypass our verification. So after 2 and a bit hours of recording this tutorial, I went off to Korean barbecue and really thought about what we could do to improve this model. Now I'm gonna walk you through exactly what I did to achieve significantly superior performance.
Alrighty guys, so you saw in V1 of the model, we had a little bit of an error, right? So this image was being verified as being positive. This image was also being verified. Now, as a business user, you'd probably take a look at this and go, hey, the value of this particular model isn't that high because it's letting someone that shouldn't be verified actually through to our model. Now, what I ended up doing is taking a look at how we could actually improve this model. So I sort of went through my standard process. Normally, I try to add more data, apply data augmentation, train for longer, and see if that improves it. If not, then we could also do a little bit extra in terms of changing our model architecture, maybe doing some additional pre-processing and going from there. But in this case, I want to take you through what I did to significantly improve the performance of this model. So if we jump back into our code, and again, this is the standard code that we actually wrote as part of our Siamese Neural Networks series. Now, I did a couple of key things, but namely they revolved around data augmentation. So what I actually went and did is I went and augmented our existing positive and anchor data to be able to produce significantly more data. So this meant that rather than training on 300 images, we trained on 3,000. I also went and improved our performance and logging metrics so you could actually see what our precision recall and just our precision and recall would actually look like. So let's actually take a step by step and see what changed in this code. So I'm going to zoom in a little so you can see that a bit better. So if I scroll on down, the first change comes right about here in section, what is that? Section 2. So what I went and did is for every single image inside of the positive and anchor class, I went and applied data augmentation. So I defined this new function here called data aug. And for every single image inside of our anchor class, I went and looped 9 times. So this would mean that for every anchor and positive image, we would now have 10 times as many images, including the one that we already had there. So we had 9 additional images for every single image we had in there originally. And I went and applied, 5 different random data augmentations. So I went and applied random brightness, random contrast, random flip left and right. So this would flip the image left or right. So the brightness is obviously going to improve or increase the brightness or decrease the brightness. The random contrast would increase the contrast or decrease the contrast. This would flip it left or right. Random JPEG quality would improve or degrade the quality of the JPEG image that we actually had, and random saturation would actually change the saturation. So went and did all of those different data augmentations. So 5 lines of code. This one was commented out. I think I actually got rid of the crop because it was a bit too much. So that gave us 9 different images, and down here, this is actually redundant code. This is just part of my testing, but you can see this is what I actually would go and do for a real model. So I went and tested on a single image to see what the impact of this data augmentation would actually be. Let's actually test that, see if it works. We need to import OS. And we need to define ANC path, which was right up here. I didn't prep to run this for you guys, but I sort of wanted to show you. We haven't imported anything. Let's test this, and data org is not defined. So if we run that, right, so this would actually go through, and we need to import UUID. Right, so this would actually go through and create another 9 images. So if I actually go into my anchor path now, I just created new images. If I go into YouTube and where are we? Face ID, applicate, it's in data, anchor. So if I take a look at data that we just created, so today is the 24th of the 10th. So you can see I just went and created all of these images here. So by running through our data augmentation, so you can see that one, I don't know what's happened there. So you can see they've got varying levels of quality, right? This, like you can see the striations. I don't know if you can see it through YouTube's video, but you can see that that's getting significantly worse. That one's got a flip applied. That one's got a flip applied. That one's got a flip applied again. And you can see significantly degraded performance in that image. And again, so that's even worse, right? So this is reducing the quality of our image so that our model at least has a better chance of generalizing and performing well. So that was all of the data that I went and ended up producing. And you can actually see right down here, let me zoom in. There's 4,899 different images. So before we started off with 300, now we had 4,800 in our anchor folder, and in our negative, we didn't do anything. Positive, we now had 3,320. So a ton of different images. So if you actually scroll, you can see that we had, this is probably our original quality image, or not even, that's probably our original quality image. And you can see that we've gone and applied flips, we've gone and applied additional data augmentation to actually produce more data to actually go and train on. So that was the key change, right? And this significantly improved model performance. So if you actually go through, what I went and did is loop through every single image inside of our anchor path, and then I switched this over to our positive path, and swap that out there, and that out there. So that basically gave us significantly more data to actually go and train on. Then I went and brought that data into our data set. So before, this would have previously been 300 over here. So we only had 300 images per data set. I boosted that up significantly into 3,000 images. So we now had significantly more data to actually go on ahead and train. And then I went and trained. So if we scroll on down, I didn't change any of this. Oh, actually, no, I changed this. So I changed the shuffle buffer size, because what I actually noticed is that when we had a significantly larger buffer, we needed to up this buffer size so that we appropriately shuffled our data set. So I bumped that up as well to buffer size 10,000. And then the final change was really the training loop. So again, no changes there, no changes there. And right down here, I actually updated this training loop. So first up, I imported our precision and recall a little bit earlier on, and I actually set it up. So remember when we were training, we didn't actually have loss or performance metrics, which is kind of a no-no because you don't really know how well your model is performing and whether or not it's gone completely off the deep end. So this significantly improves the ability to log out our precision and our recall. So first up, I created a recall and a precision object. I then updated it for every single batch. So r.update state would update recall, and p.update state would update our precision. And then I logged out those metrics. So first up, I logged out our loss. So I managed to get that working as well. I logged out our recall. So r.result.numpy would give us our recall, and p.result.numpy would give us our precision. And right down here, you can see the actual performance metrics. So on epoch 1, we had a loss of 0.857 we would have a recall of 0.944 and a precision of 0.995. Loss dropped to 0.16 on epoch 2, got our precision recall of 0.979, our precision of 0.99, and then I trained for 5 epochs, and I think I actually stopped under epoch 6 because we were pretty good, right? So our loss was 5.01 to the power of negative 0.5, and then we had a recall of 0.996 and a precision of 0.996. So again, still a very high performing model, but we're not getting those ridiculous precision and recall metrics of 100%. Then I also updated the evaluation to actually calculate it on the entire test data set. So this gave us a recall of 100%, which again, still a little bit sketchy. I'm always suspicious of that. And a precision of 0.998. So again, way better. The last and final thing that I did is I saved this out as Siamese model v2. So again, this is part of the process, guys. When you're actually going and building a machine learning model, remember you need to iterate. It doesn't just stop after you've trained it once. You need to go through, ensure that this model is performing well. So under v2, I ended up saving that. So you can see that right inside of our root folder, I then had a Siamese model.h5 and a Siamese model v2.h5. And what I did is I took that model and I dumped it into our app folder. So we then had a Siamese model v2.h5 inside of there. And to actually bring this into our application, I changed the model that we loaded inside of this line here. So rather than loading tf.keras.models.load model, Siamese model, so previously it would have been this, I just changed it to v2. That allowed us to bring in a second version of our model. Now, this is model ops in a little bit of a sketchy way, but you can see that really quickly you can go and change, update your model. So if you wanted to train this on yourself, really easy, right? You can just go through that same workflow, retrain your model to be able to go and train a verification model on yourself. But now the part that you've all been waiting for, to actually see what the model performance is like. So inside of our app, I actually dropped the detection threshold and the verification threshold, but you can choose to leave it high if you want. I found that a detection threshold of 50% was a little bit more appropriate, and I left the verification threshold at 80%. But let's actually go and test this out. So again, we can start it up using Python faceid.py. Coffee break. Right, so that's me. So if I take this out, so on the green screen, let's try it. So in this particular case, I'm getting unverified. So let's drop the green screen. We're now verified. So you can see with a green screen, it looks like it's saying, hey, that looks a little bit sketchy, but we've still got a reasonable number of verifications. We had 29 and 0.58. Dropping the green screen, we're now absolutely 100% verified. So down here, you can see that it's saying all 50 images surpassed and matched. We had a 100% verification threshold. You can see that the model is now a lot more sensitive, right? So before it was passing if I put my hand up in the screen. So let's try that. So you can see that that is now 0 verified images, right? So by throwing up my hand, it's now saying no, that there's no way that that is actually appropriately verified. Now, let's do the almighty Robin Williams test. So this was the one that I was a little bit worried about, because I was like, Robin Williams, no way should he be passing through and getting through our threshold. So if we go and test him, drop the screen down so we don't have so much glare. So you can see he is unverified. The model is working, right? Let's test that again just to prove that I didn't mess around. And let me show you in the image folder as well. So if we go into app data, input images, so it definitely is picking up old mate Robin. So let's try it again. Come on, focus. Right, again, unverified. Unverified, unverified. You can see significantly better performance after going and applying that additional data and retraining. Let's try another example. So I was testing this out on Chris Rock. So again, here's unverified. And let's test out old Jim Carrey. Can he get through our verification process? Nope. So absolutely 0 images verified in that particular case. Let's try me again. Verified. 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 And there you go. That is our app now updated and performing significantly better than what we had before. So this really at least gave you the chance to see what it's like to build a real-life data science model. It's not going to end after you train just once. You need to go through and performance tune to ideally ensure that you get the best possible model that you can definitely get. So remember, what I ended up doing is I added way more images after performing that data augmentation and improved our logging metrics so we could actually see our performance as we're training. And what I'll end up doing is, if you want, let me know. I can try to share the actual trained model. Might not necessarily work for you, but this will at least give you a chance to see how big that model is. I think it's about 150 megs. I'll have to work out how to get it to. But that actually allows us to go ahead and perform our facial verification. So in a nutshell, we are now finally done. And that definitely concludes the Siamese Neural Network series, where we attempt to produce a state-of-the-art model from paper all the way through to code. And we finally got it working reasonably well. But on that note, thanks again for sticking around. That about does wrap it up.
Thanks so much for tuning in, guys. Hopefully you enjoyed this video, and thanks for sticking along for the entire series. I know it's been a little bit of a long journey, but we finally got there and we finally tested it out. If you do have any questions, comments, or queries, hit me up in the comments below. I'm more than happy to help you out. But thanks again for tuning in, guys. Peace.